Hello guys, so today we are going to be talking about inheritance in Solidity, alright? So with that being said, let's get straight right into it, okay? So inheritance literally is an object-oriented programming concept of actually enabling other contract to be able to access variables and functions of the base or parent contract, alright? So right on my screen here, we can actually see four contracts which have already been written here, okay? We're going to actually demonstrate how you can be able to use the concept of inheritance within these four contracts, all right? So let's get straight right into it, okay? So let's assume that actually we have a certain contract, okay? We have contract A, and it has a state variable of string. I'm going to give it a variable of internal, and let's just call it X, all right? And this, it has a function called get A, all right? And you are going to give it the variable scope of external, meaning you can only be able to access this contract out of we can only be we can only be able to access this function out of the contract, right? Not within the contract itself. It's important to know this. Okay. So let's give our function as such. Let's define x and we can give it let's give it a string value of the concept of inheritance. Okay, so this function is going to be we are going to only be able to access this function out of the contract. Okay, it's quite important for us to know this. All right, so assume that we have this. Okay, we are equally going to have another state variable. All right, let's give it a units internal. If you don't understand the use of these variable scopes such as internal, external, public, and private, I actually made a video on how you can be able to use these variable scopes, okay? So if you can't understand what I'm doing right now, you can always check out my previous video where I explained on how you can be able to use these variable scopes, okay? So let's continue with what we are doing right here. So we actually have a variable uint internal, and we are going to give it a variable name of sum, okay? We are going to design a function, and we're going to call it sum A. So this function is going to also be external, meaning we are going to be able to access this function just out of the contract. So it's going to, let's say we have uint A is equal to 10, and we have uint B is equal to 20, for instance. So the sum should be equal to A plus B. It's just a basic function, okay? We are doing this basic function just for us to be able to understand the concept of inheritance, right? So let's assume that this is contract A, okay? So now the concept of inheritance, simply now we are going to, with the concept of inheritance, we want to be able to use contract B to be able to access all this, the variables, at the same time, the functions of contract A, right? It's important for us to know this. So to be able to make this possible, we need to always use the keyword is A, okay? By using this keyword contract B is A, it simply means that in contract B, we can now be able to access the function sum A. We can equally be able to access the function get A. At the same time, we can equally be able to access the state variables such as the X, the string X, and we can equally be able to access the sum value, okay, which is the sum of A and B, okay, when this particular function is called. All right, so let's see how we can be able to do this. Okay, remember, based on what we are doing, contract A is the parent contract, while contract B is literally the child contract, okay? The child contract is inheriting from the parent contract. So let's say in contract B, which we have assigned to equally be a child of contract A, we can literally give it a function as, let's say, get AST str, and we are going to make it this function to be external. well as view, meaning we can be able to access we can be able to read. When we use the keyword view, it simply means we can be able to read the state variable, right? So since we're inheriting contract A, we're inheriting from contract A, we have state variables such as sum, and we equally have state variables such as the string, okay, string X, right? So with the views keyword in this contract, we can be able to use this state variables, okay? It's very important within our function, because the view keyword allows you to be able to read the state variable but not to be able to modify the state variable, right? It's important for you to note this while you're doing your coding. So let's say this function is going to return a string, right? It's a string, and let's make it memory. Right, and within this, we are going to equally return, we're just going to say return X, okay? Now this returns X without an error because, like as you can see in this particular contract, we don't have X defined here, but we have X defined in the contract A, that's the parent contract, which B is inheriting from. So all the functions and variables which actually are available in the parent contract A are equally accessible in the child contract B, okay, just because we use the is keyword, okay? So if I actually remove this, like is A, you can literally see we have an error here, right? And if I put is A back, is A, for example, if I put is A, you can literally see that problem is solved. Likewise, if I should remove the views keyword, I'm actually running into an error because literally this function is assessing, it has the ability to read the state variable, okay? So since we are reading the state variable, what is a state variable? This is literally one of the state variables which we have designed. You have two state variables in the base contract, and this is it which we are trying to use here in contract B, okay? So it's important for us to know when to use this keyword. It's quite important, and in my previous videos I actually explained detailedly as to why it's important for you to know when and how to use these keywords, okay? So let's say in contract B, this is all what we have, right? And let's say in contract C, let me make it a little bit clear for us to see. And in contract C, we have in contract C, we equally have a function, and this function we can call it get a value. All right, and within this, we are going to within this function, we are going to make it external, meaning it cannot be accessed within this function, within this contract rather. And let's make it view and returns, let's say it's going to return a unit value, unit. Let me put an S right here, returns. Okay, and let's say this value is just going to return, let's say this function is equally, we're going to make it to inherit the first contract, so is A, okay? So we are going to be able to access, within this function, we want the ability to be able to access the sum function, right? So we can say return sum, right? So what are we doing? In the second contract B, we made it to inherit the first contract, okay? And within this contract, we had a function which returns the state variable X, okay, which was a string, right? This is what we are returning, which was from the first contract, okay? So this function here, when this contract is deployed, what happens is this particular function is going to run and is going to set our state variable to the concept of inheritance, right? So when we actually run contract B, this function get a string literally is going to call the X variable. That means what we are going to be returning here is the concept of inheritance, right? But rather in contract C, we literally make contract C to inherit from contract A, meaning that contract C literally becomes a child of contract A, right? So we can be able to access both the state variables and functions of contract A, okay? And what we are literally inheriting from here is the sum variable scope. Okay, is the sum state variable, right, which literally was initialized when this function runs, is going to add 10 plus 20, a plus b, literally giving some a value of 30, implying that when literally this smart contract is deployed, the get a value is literally going to have a value of 30. Okay, remember we are not writing the sum function here. This function is being inherited from the first function which was defined here, right? So it's good for us to understand this. So this helps a lot in the sense of it makes you to be able to reuse code without redefining the code. Rather than us writing the sum function twice or thrice even, we literally just wrote the sum function just once, okay? And all what we are doing here is we are using it here. We can use it in multiple instances. So that's one of the use cases of inheritance. It makes you not to be able to write multiple codes over and over and over, okay? So it facilitates code reusability. Right, so let's say in the next function, in this final function which we have here, all right, we have the caller function. We can create an instance, okay, of the contract B, like for example B, okay, we can just say contract, say control Z, we can just say contract B is equal to new B. Right, this is how you actually create an instance of a contract. Okay, we're creating an object of contract B, meaning you can be able to use this definition which we have created here to access the content of contract B. Okay, it's very important to know this. So let's create another object. Let's say C, and let's name it contract C. Let's continue C and such. So this is how we are going to actually this is how we create an object of a contract. Okay, wow, notice how rather than saying here is B or saying is C, we just literally created an instance. With this, we can equally be able to access both the variables, the state variables and functions of contract B, same like that of contract C. Okay, and remember in the concept of inheritance, we equally have this one way of doing it. You can equally just, if you don't want to use it as such, you can just equally say like is B, okay, or you can equally say is C. But if you want to like inherit from both contracts, that's literally multiple inheritance, you can say is C, comma, then B. Okay, literally this does the same thing too. If you do this, then you don't necessarily have to do this. Okay, don't necessarily have to do this. Like is C and is B literally inherits from the contract C and from the contract B at the same time. Okay, so if you do this, you don't necessarily have to create the objects. Otherwise, you can equally create the objects if you wish to, right? So in this particular one, we are going to be creating the objects, and let's see how we can be able to use the objects as well. So after creating the objects, we can literally create a function, just a function, and we are going to say test. Let's call it test inheritance. Okay, and this function is going to, I'm going to make it public. The same like it's going to return some you can make it to actually return two things at the same time. The function in Solidity has the ability to return two values or data types at the same time with the order of specificity. Okay, so we are going to start by returning a string memory, comma, at the same time units. Okay, so within this we are going to return contract from contract B, the contract B. Let me just write the return statement at the same time. Let's just say return. Let's do this. Do this at the same time. So we're going to say return contract B. Remember, this is an object. Okay, this is B. We actually have an object of B known as contract B. So we can be able to access content of contract B. Okay, remember our contract B has a function called get ASTRO. Okay, literally returns X, which X is a string value literally known as inherited from A, which is the concept of inheritance. All right, so literally contract B returns a string value of the concept of inheritance, while contract A returns the sum, okay, because sum literally is a state variable which literally is being assigned the value of 30 when this function is being deployed, okay. So we can say contract B returns the value of contract B has a function get str which returns a string, and contract C has a value of get a value which literally returns a sum, right? So in this, we are going to say return contract B dot get astr, right, comma, and we are going to say contract C dot get a value, right? So with this being said, I'm running into some errors right here. Okay, these are functions, so we must always have parentheses at the end, right? So with this being said, when you actually when this function is being called, this is a pure demonstration of inheritance. Remember, in the caller contract, okay, we literally have created an object of the contract B and an object of the contract C, and we are writing a function which is literally going to return functions from both contract B and contract C, okay, because from contract B we are getting the get astr, the string, okay, and from contract C we are returning the get a value, okay, which literally is the sum, right? Remember that these functions were not defined in this contract, they were defined in the contract A, right, which literally contract B inherited, right, and contract C equally inherited from contract A. So if you didn't understand what was being said in this video, you can equally always rewatch the video, and you're going to understand these concepts properly, because this is the use case of inheritance. It actually makes you not to rewrite codes multiple times, which probably if you had redefined it just once, you can be able to reuse it at different instances. All right, so with that being said, I look forward to seeing you guys in the next